And so next we have Anirban Naskar.
I'm going to start with a very sad story of an accident that occurred back in 4th of March, 1965, oh, in a small town of North Louisiana. So 6:03 a.m. in the morning, a violent blast that shook the building across the area. 5 houses are destroyed, 17 people were killed. A fireball formed following the blast, and the flames shot up to 100 feet into the air. And the main culprit behind such a huge scale of destruction is a small crack, which is not bigger than your fingernail. So, when a steel structure, stainless steel, comes in contact with a stress and chloride solution, that causes a crack to form on the steel surface, and which further cause a destruction in the pipeline steel. So, this single incident made everybody aware who is using stainless steel that how to use it. So one of the major industry that uses stainless steel is nuclear industry. So in nuclear power plant, we use nuclear canister or stainless steel canister to save and hold the waste of the nuclear power plant that you can see on the left hand side of the slide. So now uh, my research comes into play. If we need to use the stainless steel and there is a chance of form of crack, so how to avoid it? So we thought, how about repairing it? So when I say repair, the first thing comes into our mind is welding. And when I say welding, the first thing comes into your mind is a welder holding a welding torch. But in our case, this is not true. We are using a solid state process where a tool rotates and travels simultaneously in order to form a solid joint. This method not only gives a good joint and also gives a very good microstructural property and very small grain size. So grains in metal is similar to cells in human body. This process made the bigger grain size to smaller grain size, as if you are restoring the youth to human. Also, we added during this process nitrogen and molybdenum for the microalloying. So microalloying, I can explain it as addition of vitamins and minerals to human body, and that will definitely give you the strength. So applying all this process, so we found we are getting a very nice joint with a very good property, and further we can avoid this kind of accident uh, in future. Thank you.
Thank you. Very interesting.
Yeah.
So as somebody who welds, I know you have to use either fire or electricity to generate the heat.
Mm-hmm.
So does your tool generate a certain amount of heat that brings the
Yeah,
metal?
so the tool basically it has like a 3 different force. It plunges down, it moves forward, as well as rotates. So this three gives you a friction force, and that friction heat energy will do the melting. It's not basically a melting. Melting is not technical term. It will do a plastic deformation. But yeah, these are the three forces that's used to join in crack or repair.
And then how do you see this used? Is this simply for large scale nuclear plants, or do
Yeah,
you
I
see
mean,
it?
anywhere you go, anywhere the steel is utilized. Now we have like the robots. You can fix the tool on the head of the robot, and you can give the parameter that you want, and it will basically do the work by itself. So there is no chance of like such kind of a blast. Like if you can repair in situ, I mean on site, if you can repair it. And this is like a very low heat input process. That means you don't have like external heat source, so there is no degradation of the material, further degradation.
Super. Thank you. Very interesting.
Yeah.